So, hello guys, Ganesh here. Welcome back to my YouTube channel .dwg Design with Ganesh. So, till the last video, I have introduced about Catia software, right? I show you what is a Class A, Class B, Class C surface, and what is a approach to model plastic parts, and what is approach to model BW parts in Catia, right? Okay, and now let's talk about manufacturing process. So the next thing we have to know about the manufacturing process, but before that I want to introduce about Catia tools. So what workbenches we are going to using. The manufacturing process is an important concept. So right now the PPTs are not available at me. Okay, so those things that I will be updated in the next video or the next sessions. Okay, the manufacturing process, which is consists of manufacturing of plastic parts, manufacturing of sheet metal parts, and the tooling access are all are covers in the manufacturing process. That is huge topic that I will discuss you later. So let's talk about more about Catia. See, okay, in Catia we will be seeing these four workbenches. Okay, for ease of understanding, I'm just making one drawing like this. Okay, see, if you are making a one part in outside, what will happen? So let's say for example, okay, you have a part like this. Okay, wait, there is, you have a part like this, and you have some cutouts at here, and you have some extrusions here, and you have some cutout here. Okay, so what will happen if you want to manufacturing a process a part like this? You are adding some materials here, and you are subtracting some materials here, right? So this is what we called additive or subtractive manufacturing process. Okay, but when we talk about modeling softwares, the ideal workflow is not this. Okay, what we have to do is in modeling, not in Catia, so you can any modeling software, the concept is same. So what you do a sketch at a 2D environment, like anything, and then you are giving a 3D feature in third environment. Okay, okay, let's say, so this is our sketch. Okay, and this is our 3D feature. Okay, so this is how the 3D modeling software will works always. So you need to draw a sketch. Okay, then after you can add a 3D feature for that. Okay, in this way you can use the 3D modeling softwares. Okay, okay, for adding an, okay, let's close this. We will be seeing in the software itself. So let's talk about the sketcher or bench now. Okay, I will be explaining the sketcher and part design workbench in this video. Okay, assembly also we will cover in this video itself. The surface we will be seeing in a separate video, because most of the tools that we are using for automotive design are related to surface design only. So that's why we will be seeing a deep study over surface design tools. Okay, okay, let's go to software. So see, I told you I will start with part design. Click on OK. So this is a Catia. So let's close. When you're opening Catia, it will open a default window like this. You can close this up and you can choose the start mechanical design, part design. If you want to make a part design, you have to choose this workbench. If you want to make any assembly, you have to choose this workbench. Okay. Okay. What I decided, I just want to cover the assembly part and sketch workbench at one video, right? So I'm directly choosing the assembly workbench. Okay, now you can see, if you seeing a product here, so that means you are in assembly workbench, right? So you have to know the difference between part, product, and a component, and a body, and a feature. So let's use one more time snipping tool. Okay, you need to know a few things. One is part, two body, three feature, and the fourth thing, I can't say fourth thing, so which is a product. Okay, component. And then product. So that means, so whenever you are accessing product assembly workbench, you are seeing product here. That means the product is the highest scope area, right? So you have to know that what is part, what is body, what is feature, and what is component, right? See, I will explain you in very simple steps. Okay, let's and whenever I'm modeling in the software, I will explain you in the deep features. Okay, let's talk about features. So if you want to make a feature, okay, feature is nothing but, so adding material, adding or removing a material. So adding or removing materials, which obviously requires a sketch. So okay, the ground thing will be sketch. Okay, from the sketch you will be, you can make one feature. So if you make one feature in one body, you can make a one body. And if you have a multiple bodies in a one environment, and then you can call it as a part. So if you have multiple parts at one place, you can call that as a component. Okay, and okay, you can call that as a component as well as a product also. And if you have the components, the combination of components and the parts, then it will be the product also. Okay, so these are basic things that you have to keep in your mind: the part, the feature, body, part, component, and product. Okay, now you can see here it is mentioned a product. That means it may have the part, number of parts, number of components, right? Okay, so here right now I'm not having any part. So there is a features which is called product structure trooper. Okay, See here, one thing I want to explain you is, so while assembly there are two approaches are there. One is top down approach, another one is bottom to top approach. So okay, so you already having the parts in your drive and you want to just export, then it is a bottom to top approach. But imagine you are not having any part and you are completely designing it from the product's environment itself, then it is a top down assembly, and which is more suitable for automotive industry. Okay, so because we cannot say this part will going to meeting with other part in this way, so that won't work like that, right? So top down approach will saves our time more, while we can fix the mating parts also. Okay, okay, this is about product structure tools. Okay, assembly workbench. So here the important commands that you have to know is, so let's okay, I will show you how the top down approach will works, and I will show you how we can use bottom to top approach also. See, you can see here, right, the component, product and part. So I told you about the product, part, component, these three features, right? So I want to have a part, I want to use a top down assembly. That means I want to create every single part here itself. So what I have to do, I have to insert a part file, right? So click on the part and select the product. That means what I'm saying, I want to add a one part in this product. So obviously the system will, the Catia is allowed you to, Catia is added one part in this product. So now what you do, you add some bodies and features in this part, so then only it will having some geometry, right? So double click on this part, you may having access to the part design tools. So this is about part design workbench, so we are covering the part design also. Okay, from this we will be covering the sketch design also. So if you want, you can model everything in the product, in the assembly environment itself, or else if you don't want, you can open it in a separate window and then you can make modeling the part. Okay, let's, for example, we will do one a simple part. We'll do one hole and shaft process. So always it should be recommended that start with a point. So make a point at origin, click on OK. By keeping all these coordinates 0, click on OK. Now you can see a point is there, right? So which will act as our reference point every time. So now click on the sketch. Here you can see a drop down symbol, right? So when you click on this, you will be seeing two more options. One is sketch and another one is position sketch. So what is the difference? So let's talk about it. So I'm choosing the sketch option now. I told you how the modeling process will works. You need to draw a sketch and then you have to give 3D feature. So what are the things that you can see here? So those are all 3D features. So if you, in order to use them, you need to have one sketch, right? So for drawing a sketch, so not only Catia, every single CAD modeling softwares will offer 3 default planes. You can see that, right? So you can see the compass here, so the x-axis, the y-axis and z-axis. So which is parallel to the x-axis is this, right? So we can call it as a top view. Okay, this is a top view which is coinciding with x-axis. Now let's talk about y-axis. So this is a plane, right? YZ plane. You can call it as a front plane. And what is the thing that is coinciding with the jet plane? You can call it as y. Okay, can call it as remaining did explain. So every CAD modeling software will offers you three planes, these three planes. So initially you have to use these planes only for creating the sketches. So after your geometry is becoming more complex and rigid, so then you can add whatever the planes you want as your desired location, right? So right now uh, we will see about the difference between position sketch and sketch. So see, I'm choosing the sketch option, and I want to sketch, but on what plane I want to sketch. See, for example, I'm choosing the top plane. See, after selecting the plane, it is directly taking me into the part design or sketcher design or pinch, right? So now what I do, so this is a exit window, exit tool, handy tool we use for getting out of the sketcher or pinch. So click on exit. So I use the sketch tool to use the sketch on the top plane. But when I use this position sketch option, what will happen when I choose the plane, it won't take me into the sketcher or pinch. It is asking some more settings. Okay, so let's see about what these settings are. See, here you can see the most important features here are these three. See what will happen. So right now you are having only three planes, but when you are going with a complex geometry shape, you are required to have multiple sketches and multiple planes also. So for example, if you are required to create a one more plane, and you are required to add a sketch on that. So if you use only sketch option, it will takes you different orientation that you cannot even imagine where you are sketching, right? So that sketch option won't allows you to orient your sketching plane properly. So on the other hand, you can use the position sketch to control the orientation of your sketching plane, right? So it is recommended that always go for origin, point at the origin, and then the position sketch. Select the position sketch and choose the plane. I'm choosing the top plane, and origin I can choose the projection point as this, and reverse the axis. Click on OK. Now you are in the sketcher workbench with the proper and most uh, practiced way. Okay, now let's see about all the tools. So I don't want to introduce more about this, because you can see the profile toolbar. By using this you can make any profile with a linear surfaces like this. Okay, so close it, delete it. So there are predefined features, so where you can access the center rectangle, all kinds of rectangles you can see here, right? So slots, those all you can use now. So I want you to play with all these tools. I don't want to waste that time on these tools. Okay, the circles, there are three different ways of making circles and three different ways of making arcs. So then after, a tool called spline. Okay, and ellipse, we don't use it most, leave it. And the line command, we use this the most. The line commands types also there. Okay, so these are the sketch based tools these are useful for, mainly used for making one usable, a 3D usable sketch. Okay, so these are called operations. So for example, you are having a rectangle like this, you want to add a fillets here. So of course you can do it in the 3D environment, but when it is a simple geometry, it is always recommended that you can give the fillets in the sketch environment itself. So select the corner option, You can directly choose the point to specify a corner like this, or else you can choose the two lines like this. Okay, if you want to make one fillet with a specified radius, select the two entities and press the tab key from your keyboard. You can see the upside, right? So radius it is displaying. So enter the value, enter. So it has created. Okay, now now the rectangle is not in a proper dimensions. So I want to give a proper dimension choices. How can I give? So there is a tool called dimension constraint. Select that. So one more thing is, if you select this, if you tap this one time, if you give one dimension, that's it. The tool is going to disable, right? If you want to keep it active, double click on this and use the feature. See, after even though I have given dimension, it is not going into disactive, deactive, right? So you can see I have given the dimensions only, but you can see the V and these symbols and these symbols, why all these are displayed and what it is. So these are called geometrical constraints. See, for example, I have given the dimension between this line to this line only. Okay, but okay, one more thing I want to explain is, I'm deleting this dimension. What will happen? You will be seeing two kinds of things, right? So those are appearing in green color and also appearing in the red color, white color, right? Okay, now let's say about what is the difference. See, the green color entities, when I try to drag them out, they are not moving from their position. But the white entities, when I drag in them, they are moving from their positions. That means these are not properly dimensioned, isn't it? So this is the difference between a constrained sketch and an unconstrained sketch. And where you can, since it is a small sketch, you don't have to check any software help. But if you want, you can do it. Here you can see the sketch solving status, which is a traffic light symbols, right? So if you click on this, you can see the sketch is under constraint. And if you want to see the things what and all are not constrained, you can see all those things right from here. See, right now I'm not having the constraints for this one. So let's give back the dimension. Okay, now if you click on the sketch solving status, you can see this is ISO constraint. That means properly constrained. So this is how so not in the automotive industry. If you are in design industry, so everyone will recommend you to constrain your sketch properly. So since it is in a Catia, it will shows the green lines for a fully constrained sketch. So if it is SolidWorks, it will show a black color sketch. And okay, yeah, different software will show you different colors for constraining the sketches. See, and one more thing is, dimensions alone are not enough a to make a to make one entity completely constrained. So how can I say? I'll say one circle. Okay, I have given dimension for this circle. So although I have given dimension, it is not fully constrained. So these are things where you have to know about the geometrical constraints. You can see this round symbol here, right? You can see the V symbol here, right? You can see other coincidence. All these symbols are, you can see that, right? So these are all called geometrical symbols, geometrical constraints. And how can we use them? See, for example, I want this point of this circle should be coincidence with this line. So what I do, I select this one, press and hold the control key and select this point also. you will be enabling this feature. Select that and choose the coincidence feature. Click on OK. Okay, now just okay, let's do this. You can see the coincidence constraint is given between these two, and one dimension is enough. If this coincidence dimension is got deleted, we are required to give one more dimension. Sorry. So in order to avoid giving multiple dimensions, so it is recommended to use the geometrical constraints also. Okay, so this is about geometrical constraints and the sketch sorting status. So let's talk about, okay, let's delete this. We'll create a one more center rectangle by specifying center and this. So next feature we'll talk about this chamfer. So fillet is a round surface, a round corner, right? So making a sharp corner into a round, but the chamfer will makes like this. Okay, so this is the use of chamfer. And for example, uh, while you're drawing, so you will be having number of sketches, and sometimes you have to trim one over another. So there is a handy tool we can use this, which is called trim. Select this and this, and select this up to this, select this up to this. Okay, in this way you can use the trim tool, and if you want to extend, double click on this trim again and you can see the here extension. So select this and this up to what, up to where you want to extend. I want to extend this element up to this element or else this element. So these are the extend and trim tool will works, and this is a break, so which is okay. Double click on this. So I want to break this single line into a number of line in two numbers based on the intersection of this, right? So select this line and this line. So what you see here, the line which is a one line which is divided into two segments. So that is the use of the break tool. And the trim, quick trim, so which is quite similar to trim. So here you don't need to mention any trimming element, you can directly choose the entity which you want to remove. So that is about quick trim. And yeah, close arc, we can remove it, we can skip that. See, first sometimes whatever the things that you have done one side, you have to reflect on the other side also. Okay, so for example, I have a sketch like this. If I am doing the full model two sides, what will happen, it will causes lots of dimensions, lots of geometrical constraints, right? So that is not recommended. So when the part is symmetry about one line, you can use the mirror feature. Okay, select this, select all the entities. Okay, in order to use this feature, you have to select all the features earlier and choose a mirror feature and choose a mirroring line. Okay, I have chosen a plane. So this is how that mirror tool will work, and the symmetry is nothing but if you use it a mirror, whatever the things that you have, whatever the things that you have selected will be projected this side also. But when you use the symmetry feature, let's select all this first and use the symmetry and choose the one plane. See, it will be transferred. So the mirror tool will copy the things from one to another, and the symmetry feature will translate it. Right? This is the difference, and this is the translation feature. So in SolidWorks, so in the sketch environment itself, so it is recommended that the translation and the corner, chamfer, and the circular pattern, so rotate. The scale we won't even use it, offset. So offset is a one tool we use a lot in sketching environment. So which is not recommended to use a translate and rotate features in the sketch environment. Okay. So although I want to explain you, so there is not any issue to me. So I have a sketch, I have circles, and I want circles at every instance of 50. I want this up to 10 elements at a distance of 50. What I do, I select this, I choose the translate option and choose the first point as this. Okay, and I want how many instances I want. I want 10 instances up to distance of 50. Okay, 50. Okay, you adjust the mouse and 50, enter. Okay, so the value is not enough, control Z. The value you can put it as, okay, 500 you can put, enter, and choose the orientation. That's it. This is how the translation tool will works. Let's delete it. Okay, okay, there will be no left to right or right to left selection in Catia, so both selections are similar to each other. So let's delete it. Okay, alright. Okay, I have to delete it. Sketch, delete, or else I will delete the entire geometrical set. I don't know how many sketches are there. They are not deleting it. Okay, exit. We can delete the sketch, entire sketch at once. Okay, we can use the sketch environment again. Select the top plane and choose a projection point as this. Align the axes. Click on OK. Okay. So till the rotate option, okay, till translate option we have seen it. So let's talk about the rotate option now. I have a circle here and I want to rotate the circle about the center. Okay, what I do, I select the rotate tool. Okay, but before that I need to select the entities, select the rotate, and I want to rotate this about the center, and I want 6 instances at a degree of 60, enter. See, so this is how you can use the rotate tool. So erase it, and obviously I don't want to explain about scale feature, so which is quite easy. I have a rectangle like this. Okay, I want to increase it, I want to double it. So what I do, I just simply do take this scale option, but before that I need to select the entities, select this and choose the scale option, choose a center point, choose one base point, and in this box you add it as 2. See, you will be having a Okay, like this. So let's delete it. So exit, delete the sketch. Okay, let's add a one more position sketch. Set the top line, projection point, select this point, swap, click on OK. Okay, okay, up to this we have completed, and this is a 3D feature. So I will explain you about this feature when we are talking about the 3D environment. Okay, I will explain you. We will see at the end of this part design tutorial. Okay, so now let's talk about more about given the dimension constraint. You already seen it. Uh, how can we use? By selecting the two entities we can use it. So apart from this, the dimension constraint is also help you to specify the geometrical constraints. How can you? So for example, I have a rectangle here and I have a circle here. Okay, delete. I want the center point to be coincide with this line. What I do, I don't have to choose this constraint defined dialog box. What I do, I'm double clicking on this dimension constraint and selecting this center point of the circle and this line. It is showing the distance, right? So right click, you can see the possible relations between these two. I can choose the coincidence, right? So the dimension constraint is not only used for given the dimensions, it is the key to use the geometrical constraints also. Okay, so this is okay. So one more feature I want to introduce is auto dimensions, automate dimensions. See, I have a sketch and I want to constrain it. I want to give the required dimensions. When I am giving it manually, it will take some time, right? So I don't want my time to spend on giving the dimensions. So what I do, I'll just select all these entities. I use the automate feature and I choose the one reference as this. Click on OK. Okay, it is not selected properly. Control Z. Let's select properly. Select the automate dimensions. Select all the features and choose. See, one circle is only selected. Okay, reference I am choosing this point. Click on OK. See, this is only forming. Okay, this is how you can use the automate constraints. So that's it, guys. That's up to Sketcher design. Okay, and few more things. Okay, few more things. What they are? You can see here. Yeah, this feature. So this we use most, and then okay, these are what we use. Okay, so this is a feature that we use most. So I'll explain you what these are in the part design. So here are the three features, and here the three features we will see in the part design. Okay, so one more interesting toolbar is this one, sketch tools toolbar. So if you want to display grid, you can choose this one, and if you don't want, you can turn it off. And this is a snap. Okay, whenever you want to construct, whenever you want to make a one line into construction, what you do, you can use this construction element option. And I told you about geometrical constraints and dimensional constraints, right? So when your sketch is complex, so that geometrical constraints will occupy most of the space. And if you want to don't want to display the geometrical dimensions, you can turn off and on them right from here itself. These two are geometrical and dimensional constraints. So that's it, guys. That's about Sketcher Workbench. Now let's say about how a part will be modeled. So what I do, I'm just taking a rectangle, so which is not construction. Okay, let's give dimension. Let's take 100, so which is very small. Okay, what I do, exit, delete this sketch. Okay, I'm adding one more sketch. Select the position sketch, select the top line, choose the origin point as the center point. Okay, I'm taking one center rectangle at the center, and I'm making dimension. Okay, again this will cause a lots of problems. Exit and choose a center point. You can see how the scale is, right? You can see the dimensions. I want to use hundreds only, but the scale is showing 1500. So what I do, I'll zoom it out a little. See, which is quite close to 100, right? So in this way I can close it. So now use the dimensions. So 100 this side and 200 this side. I have a rectangle like this. Now what I want to do is, see, my sketch orientation is changed. So what I do, I can use the normal tool option. Okay. Okay. So now I want to add the fillet also. Select this fillet option and make a window selection like this. So what will happen? It will select the every single corner, which can be used for corner. Okay. Let's consider it as a 10. Okay. Yes, fine, right? So now I have one rectangle with fillets. Now exit. See, I told you we need to have one sketch to use 3D features, right? So first 3D feature I'm choosing this. So okay, and I'm choosing this sketch. See what it is doing. So it is making one part 3D part, right? So it is adding the material. Similarly, if you want to remove the material, you need to have a sketch. So for that, click on the position sketch, select this face as a sketching plane, and origin point you can choose this same as again. And this time what I do, I'll just take one circle here. Exit. Okay, I'm not given any dimension. Double click on the sketch to edit it. So I'm given the dimension for it as a 40, and now exit. So the pad is a feature that we use it for adding the material. So same opposite, so we can use the pocket for removing the material. Select the pocket and select the sketch and click on preview. You can see it is removing the material, right? So click on OK. Now what I do is I want okay I want to reduce this whole dia. What I do, I just go to the sketch for this pocket, right? So double click on the sketch, you can edit it. So I'll reduce it to 20 only. Okay, that's fine. Now what I do, I want these holes to be format at these corners also. So in this way I cannot use the rectangle pattern or circular pattern. So what I use the user pattern option. So but before that I have to do something to use that. So click on the position sketch, select this plane and choose the projection point. Click on OK. So what I do, I'll specify 4 points Okay, one is here, one is here, one is here, and one is here. Now these points are not at the center of this corner. So what I do, double click on this dimension constraint, select this point and this arc, right click, concentricity. Select this arc point, right click, concentricity. Select the point arc, right click, concentricity. Select the point arc, right click, concentricity. That's it. Exit. Now what we do, we discussed it, right? So select the user pattern. So position I can choose this, and here's the important step you need to consider. So object to pattern, it is always takes the current object. So you need to select the pocket feature. Okay, so click on OK. So what it is doing, our diameter of this hole is still too large. So what we do, double click on the sketch, we'll reduce it to 15. Exit. Now see, it is okay, right? So in this way you can use the user pattern. Okay, similarly you can use the see, we have using the chamfer feature in the sketch, fillet feature in the sketch environment. So in this way now we will use the same in the part workbench up to 1 mm preview or else 2. Okay, you can see that the round corner is applied. So we'll use the chamfer on the both other side up to 5 preview. Okay, so this is the difference between chamfer and fillet, right? So let's delete this chamfer and fillet also. Okay, I told you the manufacturing feasibility. So when you're having the flat walls like this, so it may difficult to eject the part out, right? So for that what we do, we slightly incline these walls up to certain degree so that it will easily come out from the core while manufacturing, right? So in order to give that slanterness for these particular walls, what we use, we can use a draft feature. So select the faces. So for the first thing, the faces to draft. So we here in this tab select the faces to be drafted. See, it is automatically selected, that is fine. And neutral element, so what it is saying, so based on the which face the draft should be acted. So I'm choosing the bottom face, that's fine. And what is draft pulling direction, it is asking again. So if you have any specified axis you can specify that, or else you can choose the Z axis. So whenever you feel confusion about what axis I have to show, you just look at your compass, you may having idea it. You can see in my case, if my pulling direction is in vertically upwards and downwards, then only I can able to achieve this, right? So the upward and downwards, it is obviously the Z plane. So select the Z axis. So click on preview. So what is a draft I want? I want 7-degree draft. Click on OK. Now see. So how can you see it clearly? So use the side view. See. So we will go back to a step earlier. You can see that, right? So here we have the 90 degrees walls, but after giving the draft we got somewhat of slanted edges. So these are the most features, guys. So you already seen about these two. See, for example, one more feature I want to explain you. So remaining all we learn by using them, so during the tutorials. So in our channel there are number of tutorials available for part modeling, surface modeling and sheet metal, and even drafting also. Okay, if you're having some free time, so please go ahead and watch those videos, so that you will be having, if you are, in that videos I have covered every single tool like this. Okay, so that's it guys, that's up to this video. So this video is already being too length. I don't want to explain the product design features. So we'll be seeing in the next video. Thanks, have a good day. Thanks.